All right. Welcome back. Like I said, just a quick heads up. You have about 3 weeks left of the semester is where we're at. You've got a full week this week. You got a full week next week. And then the week after that is a 4-day week of that last Friday off. That's our grading day to put together your semester grades. So the reason I start with that is if you remember before break, we started just the first section of chapter 5. And I gave you the 5.1 worksheet. The 5.2 worksheet was in there as well. We'll worry about that later in the week. But the 5.1 worksheet, if you remember, was what's the general shape of a cubic function look like? What does a quartic function look like? What's the end behavior? Those types of things. Just kind of talking about the general ideas of the different functions that we're going to look at in chapter 5. Okay? I'm going to focus more on that on Wednesday. Okay? Because that'll kind of introduce section 5.2, where we go with that way, we'll connect those. So for today, what I wanted to do is because the test, you've got one last test for the semester to try to hopefully improve your grade. That final test will be probably 2/3 of it will be on chapter 4 again, still talking about quadratics, vertex, x-intercepts, all that kind of stuff. And then the last third will be on the first 2 sections of chapter 5. Okay, one of them we've already done, which we'll reintroduce, and the other one we'll do on Wednesday. Okay, so you'll have some time. Next Monday and Tuesday will be a review day. You'll have a chance where we can just kind of go over some stuff, go over questions, get ready for the test, and then next Wednesday is your test. Okay, so just a heads up that next week, end of next week is when you're going to take that test. Okay, so what I want to Is that like going to be? No, we're not going to do a final exam. That'll just be your final test of the semester. Yeah.
We're gonna have like ACT. Is it ACT or ACT?
Review ACT.
Yeah, we're gonna do ACT.
I've been holding off only because like last year they didn't have to take the ACT because of everything with the pandemic and stuff. Right now, juniors are currently scheduled that you do have to take the ACT, but that might change. That's why I've been waiting. That's why I haven't done a lot of it yet, because of the fact that if you don't end up having to take it, then we don't have to worry about it. Right now, you're still scheduled to have to take it this year. They have not exempted everybody yet, so, and they might not. I don't know. But as long as we do it, then we'll start getting into some ACT review second semester. Okay. So what I have for you today, what I want to focus on today is the chapter 4. Going back over that stuff. That part, Taylor. That chapter 4 stuff. Refresh your memory on a lot of that stuff of how do I find the vertex in different forms? How do I find the x-intercepts? Some of those types of things, because like I said, that will be a main idea on this next test. And then we'll get into the chapter 5 stuff later in the week. First question though. Does anybody not here that needs the 5.1, 5.2 worksheet from before break? Grab those. I think everybody was here. Second question, does anybody need the formula sheet? I would take that out as well, by the way. You're going to be able to use this on your test. Okay, you'll be able to use this, so you'll have some information here for you to help you out. I'm also going to let you use one other thing as well, and that is, if you remember back to this sheet, the chapter 4 review concepts that I handed out to you, I'm going to let you use this on your test as well. That way, it'll guide you a little bit. If you have those, why don't you take those out? Does anybody need one of the chapter 4 review ones or the formula sheet at all? And I think most people are there. If not, I did copy off extras. So, okay. So then I've got a couple of things for you today. Here's where we're going to start. I'll give you this. We're going to go through a couple of these together. And if you were really struggling on the chapter 4 material yet, okay, today is the day you really need to make sure you're paying attention. You're really making sure you're trying to understand everything we talk about today, because I'm going to kind of go over a little bit of everything that you need, the main ideas. So really focus if you're struggling on chapter 4 today, because it'll clear hopefully a lot of things up. But starting with that worksheet, the chapter 4, and then 5.1, like I said, review. We'll worry about 5.1 in a couple of days. This is the sheet that I just handed out to you. And the reason I like this is it kind of breaks down a little bit of everything that you have to find. Okay, we're going to add some stuff to it as well. I'm going to pick 2 of these to go over. Okay, the first one I'm going to take a look at is problem number 4. And if you notice, by the way, I didn't mention this, but if you notice on the back side of this sheet, I did put the answer key. That way, if you're working through the front side, you're going to need to be able to do it on like a separate sheet of paper or something. But if you're working through the front side, you can then quickly check the back side to see if you're doing it right or not. I wanted to make sure I had these. I thought about putting them out on Canvas again, and I thought, no, I want them in your hands. I want to make them easier for you to be able to access so that you can check right away if you're doing it right or wrong. So let's take a look, though, at number 4, okay, as we work our way through it. And like I said, you may want to take out a separate sheet of paper because there's going to be some work and stuff that you have to do in order to find x-intercepts, things along those lines. And I'm just going to kind of list this as like A, B, C, D, so on and so forth. Just kind of work our way through it. We'll just work our way through the different pieces here, okay? So part A, if you will. On the sheet it asks you, what's the direction that this parabola is opening? Is it opening up or down? And how do you know?
It's negative.
Yeah, you got a negative A value. So you know that this is opening down. There's your first part. Okay, so if you were going to graph it, and that's kind of the whole point of why you find all of these different things, is so that you can take a look at the graph and be able to graph it accurately. I'm going to skip to the vertex column next, because that's the most important point. So I'm going to go to the vertex next. I'll put that as just as part B. Vertex. So first question I have for you, and this is where your formula sheet's going to come in handy, is what form am I in? Am I in standard form? Am I in vertex form or intercept form? Standard form, okay? So how do I find the vertex when in standard form?
Negative B.
Yep, opposite of B over 2A, and that is on your sheet, okay? That's on your formula sheet, it tells you that. So if I'm going to do that off to the side here, right here, x equals opposite of B over 2A. So if we take a look, the opposite of B is negative 10. And if I double my A value, I get negative 4. Well, negative 10 divided by negative 4 is not the nicest thing in the world, but we do end up with 2.5. So the x coordinate of my vertex is 2.5. How do I find the y coordinate? Plug it back in, okay? And the one thing I want to mention is when you plug this back in, make sure you put parentheses where you're plugging it back in, because some people were struggling and getting some things wrong on the last test. When they plugged it back in, they didn't put parentheses in some spots, okay? So when you plug that back in, you have negative 2 times 2.5 squared plus 10 times 2.5. And then you have the minus 12 at the end, okay? That is what y, that's what your y coordinate will equal. And that you can then just plug into the calculator. But you, again, the biggest thing I can stress is make sure you put parentheses around whatever you're plugging in. Okay? And what do we get? You do it correctly, it answers are on the back. What does it say? A half, looks like. So we get 0.5 is what you should get as an answer. Okay? Positive 1/2. I don't know, because that's what it said on the back side. I assume that's what, when you type it in, that's what you get. Yeah? So all you're doing is right here, Michi. You're just typing this into the calculator, and that should equal half. All right, so we found our vertex. The reason I started with that is, like I said, that's the most important point on a parabola. Everything starts from there and either goes up or goes down. Well, in this case, there's my starting point, and we already know everything's opening down from there. Okay? Let's go to, which, by the way, as long as we're on this, I'm going to call part C, axis of symmetry. I'm just going to say AOS. Which means I'm looking for the equation of the line. What's my equation of the line for the axis of symmetry here? Yeah, goes right through the vertex. X equals, because it's a vertical line. That's the equation of all vertical lines. Remember back to Hoy, Bucks, vertical lines are X equals equation. So X equals 2.5. That's your equation of your axis of symmetry. Okay? Now if we go one step further, I'm going to go to the y-intercept next. And the only reason I picked the y-intercept is because that's fairly quick and fairly easy to find. So if we, y-intercept is when? Well, it's the c value if you're in standard form, so that's one way. So we know it's negative 12. Or let's say you forget. How do you always find the y-intercept of any type of equation? X equals 0. So if you were to plug in 0 for your x's, you'd be left with negative 12 as your answer. Okay? So even if you can't remember that c is your y-intercept, that'll save you some time. You can always calculate it, and that's on the back of this sheet that I was talking about. Right up at the top, it says y-intercept when x equals 0. Okay, so it's a reminder there as you're working your way through it. So if we type that in, my y-intercept then is 0, negative 12. All right, so we found the vertex. We found the y-intercept. I've got my axis of symmetry. I know it's opening down. And so now the key part that's left is I still need to find, on the sheet they call them zeros. It's the same thing as x-intercepts. Okay, and I think we talked a little bit about that before break. But if you hear the word zeros, x-intercepts, roots, those all mean the same thing. Okay, so that zeros column, if you want to write in there, if you want to put in there x-intercepts, that's what we're finding. All right, how do I find x-intercepts? Yeah, it's when y equals 0. So you're going to take this equation, set it equal to 0, and solve, which you have two methods of doing. What are they? Quadratic formula or factor. Okay, so if we go through and we do that, and this is where I'm going to add some stuff in. So for part E, I'm going to say we're trying to find the x-intercepts here. And that is when y equals 0. So like we said, we have negative 2x squared plus 10x minus 12 equal to 0. And now we either factor or use the quadratic formula. Now this is where I'm going to add something in. Because remember, you can't always factor. You can always do the quadratic formula, but the quadratic formula is kind of long and there's a lot of places where you can make mistakes. So my opinion always is if I can factor, I usually do it, okay? If you want to always do the quadratic formula, you can. But here's where I'm going to add in the idea of the discriminant, okay? So in those last two columns on your sheet that are kind of blank, what I'm going to put in one of those is what's the discriminant, and then I'm going to ask you kind of what it tells you. So let's find that next. Discriminant, remember, is what? What is the discriminant? Let's start with that. B squared minus 4ac. It's what's under the square root in the quadratic formula. Okay? So let's start with that part. Let me come over here to that. So I'm going to put down the discriminant, which is b squared minus 4ac. We're getting an answer for what's under the square root. So if we take a look at our equation, b squared is 10 squared. And again, parentheses every time you plug something in, okay? It's not going to matter here, but it's something you should just get used to. Minus 4 times my value of a, which is negative 2, times my value of c, which is negative 12. So we're plugging those things in, and I'm going to see, what do I get for that value? So if we evaluate this, 10 squared is 100. When I multiply these three numbers together, will I get a positive or a negative? Yep, I got 3 negatives, so that'll stay negative. 4 times 2 is 8. 8 times 12 is 96. Yeah? Yeah, thank you. And now if we take a look, 100 minus 96 means my discriminant is 4. Okay, so that is the value of the discriminant. What does that number tell me? It should tell you two things. One, it's factorable. How'd you know that, Taylor? You're right.
It's 4 square root.
Yep, perfect square. So therefore, I know what you meant. So 4 is a perfect square, which means we can factor that when I find the x-intercepts. And because it's positive, how many x-intercepts will I get? 2. That's what it tells you. It tells you how many x-intercepts and whether it's factorable or not. Okay? So that's the idea. So this number tells me two things. I will have two x-intercepts, and it tells me it is factorable. So on this problem, let's actually go back over factoring. Okay? Let's actually go through and factor this. First rule of factoring. Take anything out. If you can simplify this, simplify it first. And in this case, actually, if you take a look, we can divide everything by -2. So I'm going to actually divide it out rather than factor it out right now, just because it's a number. Okay? If it was a variable, I'd pull it out. But I'm going to divide everything, both sides, by -2. So therefore, I end up with x squared minus 5x plus 6 equal to 0, and that is now what I'm trying to factor. And if you remember back to factoring, here's kind of a method that I'll give you just in general. Remember the idea of foiling? We talked about FOIL before, okay, where you multiply things out, you FOIL it out, you distribute it, whatever you want to call it. Well, we're focused on the first and the last. Factors of the first term? X times x. That's what goes in the first spot. Then we go factors of the last term, okay, which in this case we've got 6 and 1 and we've got 2 and 3. Which I'm going to start with 2 and 3. And here's where the whole O and I come into play. If you remember, you check the outside and the inside to see if you can get that middle term. Okay? And you got to keep in mind the signs. So I end up with a 2x and a 3x. I can get 5x. Hey there. What's up?
Do you have a PD smartboard lesson for today?
For geometry?
Yeah.
Yes.
Can you email it to me?
Sure.
You know, when you're done here or something?
Yeah, we'll do.
I know.
Yeah, I'll send it to you. No worries. Thanks. Yep. So I do get a 2x and a 3x, which I can get 5x from. If the signs are what? I need a negative 5x. Both negative. Now, the other thing to check. When I multiply those, do I get a positive 6?
Yeah.
I do, okay? The reason why I bring that up, and I don't write this down, but I want you to see this. Let's say that I would have put in 6 and 1. I get a 6x and a 1x, right? Which I can still get 5 from, but then I would have a negative 6 and a positive 1. But that doesn't give me a positive 6 when you multiply, okay? So I just wanted you to see that you also have to double check the sign of the last term. Because in this case, there's 2 different ways to get that 5x, okay, that work out. Normally that doesn't happen, but in this case it did. All right, so let's get rid of that. So now I factored, I have not solved. And this was one of the problems, again, that some people had on the last test. You got to the factoring point, but you didn't finish it up, okay? Remember, this is where the zero product property comes into play. You set each factor equal to 0 and solve. Which means I add the 2 over, there's one of my x-intercepts. And I add the 3 over, there's the other one. There's your x-intercepts right there. So we factored in order to find our 2 x-intercepts. And again, if we keep putting stuff together, let's keep making connections. Where did we say the vertex was? What was the x-coordinate of the vertex?
2.5.
Which just happens to be right in the middle of your 2 x-intercepts. Okay, so just confirming that, oh yeah, that makes sense, that our vertex was 2.5 and my x-intercepts are 2 and 3. Okay, so there's that symmetry that you're looking at. Last thing then, last 2 things that kind of go together, and that is the idea of domain and range. Okay, so let's put those, I think we're down here on G, I think is where I'm at. Let's talk about domain. We'll just do both together. Unless we are in an application problem, what's the domain of all quadratics?
All real numbers.
All real numbers, okay? And we'll talk about an application problem today as well, so that we can revisit that idea. How about my range? I know I've got a high point. We said before, it's opening down. So are my y values less than or equal to something or greater than or equal to something? If your graph generally is going to look like this. They are less than or equal to your high point. Because you've got a maximum, all the y values are less than or equal to that maximum. If it opened up, all your y values would be greater than or equal to that minimum. Okay? So my range is y is less than or equal to, and what was it? A half? Is that what we had said?
Yeah.
There's your range. All of your y values are less than or equal to that maximum value. How are we doing? Making some sense, hopefully? Because this is pretty much a summary of almost everything we did in chapter 4. It's not everything, but it's got a little bit of everything that we talked about. All right, let's take a look at another one of those, a little different version. If you notice on your worksheet, problems 1 through 5 are all in standard form. Problems 6 through 10 are all in intercept form. And then 11 through 14 are in vertex form. What I'm going to tell you is as we move forward, focus on standard and intercept form. Okay? Because those are the two most common forms. Those are the forms that we're going to use most often when we're in chapter 5 now. Okay? So focus on those two. Don't worry as much about vertex form as the other ones. Which means the other one that I want to take a look at is number 9. One of the ones that's in intercept form. Intercept form or factored form, whatever you want to call this. First question, is this parabola going to open up or down? Down. Once again, we've got an a value that is negative, so this opens down. All right, let's find the vertex. How do I find the x-coordinate of my vertex?
Isn't it just a?
That's vertex form.
Oh, yeah.
If you were vertex form, then that's what it would be, yes.
Oh, it's between the 2 points.
Yep, this is intercept form. There's your x-intercepts right there, which means it's halfway between, like we just talked about in that last problem, okay? Which actually, let me kind of, want to put axis of symmetry in here, which we'll talk about in a second. I'm going to go right to the x-intercepts. What are my x-intercepts?
1 and 2.
Yeah. All you got to do at this point, it's already factored for you. Just do the zero product property. X minus 1 equals 0, x minus 2 equals 0. So my x-intercepts are 1 and 2. Which means, where's the x-coordinate of the vertex?
1.5.
1.5, yep, right in the middle. Which means, as long as we're on this connections, what's the axis of symmetry?
1.5.
X equals 1.5 is the equation. X equals 1.5 is your axis of symmetry, that equation. Okay, that's your line of reflection. All right, last question then for this stuff. How do I find the y-coordinate of the vertex? What do you do? Not plug in 0. Yeah, plug in the x coordinate, plug it back in. So if we do that off to the side to get our y coordinate, I have -2 times, if you plug 1.5 in here, what do you get for an answer in this parenthesis? Yeah, you get a half, right? So I would get a half here. And if I plug in 1.5 here, what do I get? Get -0.5. And now, in order to get an answer, we just multiply those 3 things together. Half of -2 is -1. Half of that is 1/2. Okay, and that should be what they have on the back side. Number 9, yep. So your y coordinate, if you actually get your answer there, should be a positive 1/2. There's your y coordinate of your vertex. Any questions so far? you can see that there's a little bit, it's a little bit easier when you're in factored or intercept form, only because of the fact that you don't have to worry about finding the x-intercepts. They're pretty much right there for you. Let's go to the y-intercept. How do I find the y-intercept?
0 for x.
Plug in 0 for x. Always. Y-intercepts are always when x equals 0. So if I take 0, and now we're going to basically do it the same way I just did, but instead I'm plugging in 0 instead of 1.5. So if I do that off to the side, I've got -2 times 0 minus 1 would give you a -1, times 0 minus 2 would give you a -2. And once again, multiply those out and get your answer. You end up with -4 as my y-intercept. All right, what's my domain? All real numbers. Not an application problem, so it's, you can square anything. All real numbers. And now again, if we go back to the range for a second, we said once again, this is a parabola that is opening down, which means, again, there's a general sketch of your graph. Are the y values less than or equal to something or greater than or equal to something? They're less than or equal to your maximum value, which in this case, again, is a half. Okay. So all of your y values will go from there down. Y is less than or equal to 0.5. Does it make sense, by the way, of why we have to have an equal to in there? Why it's not strictly less than? The equal to means where you're including that.
Sorry, you specified, I start during 7th period, so I actually need.
Do you need it right now?
Yeah.
Okay, let me pause and I will grab it for you.
I'm sorry.
That's okay, no worries.
I know, Taylor.
I'm so disappointed.
I
in you.
know, you're always
I
disappointed.
know.
Oh,
I know.
sorry, guys, you can blame me for, the fact that you won't learn this math. I mean, put it on me.
I got it, hang on, I
All
got it.
right, thanks, Peggy.
Yep. Okay, so going back to this problem, there's your general idea. I told you these are kind of the two to focus on because this is where we're headed, even in factored form, that's where we're headed in chapter 5. We're going to use factored form a lot more. And there's not so much of vertex anymore because now we've got multiple changes of direction. So it's a little bit different. Let me stop there for a second. Questions at all on either of these? Anything that did not make sense? Because I'll tell you, this is the main idea, what you need to be able to do. Okay? Yeah. Yeah.
It says zeros.
Zeros are x-intercepts. That's just another word for x-intercepts. Okay, so now let me give you the next part of it. I'm not going to make this necessarily an assignment. Okay. Matter of fact, nothing today that I'm going to give you this chapter 4 related am I going to make a specific assignment that has to be turned in. I'm just giving you plenty of things that you can work on to make sure that you know what you're doing, okay? Because that's what I care about, is I want you to know what you're doing, not to have to turn these in specifically. So the rest of these problems, you can do as much or as little as you need. Again, you've got the answer keys on the backside, okay? The answers are there. The other part that I'm going to give you is this. This is basically the rest of your review to get you ready for the test. Okay, so if you take a look at this, like I said, is a little bit of everything else, okay? So the first thing that I have, here's some problems right here on the front side. Again, the very first worksheet, graph me and stuff that's in standard, vertex, and intercept form. Basically, if you're doing these, I would do the exact same thing we just did. Find the vertex, find the x-intercepts, find the y-intercepts, graph them. Once again, answers are on the backside, okay? Now, I don't have all the work and all the parts on the backside, but I do at least have the points, pretty obvious, that are there, so you can at least check to see. Okay, so hopefully that gives you a little bit more practice. The next thing I want to take a look at is one of the application type problems. And rather than the front side, I'm going to actually go to the back side of this sheet. And I'm going to actually go all the way down to number 2 here on the back side. And we'll do this one together. Because once again, there will be some application as well as you take a look at your test. All right, so let's kind of take what we just did and now apply it to an actual scenario. Okay, so Carter throws a paper airplane in the air. The function y equals negative x squared plus 5x or plus 4x plus 5 represents the height in feet y of the paper airplane x seconds after it is thrown into the air. So first thing, if you're trying to define what is x, what is y, right here, there's your y value right there. The y is how high the paper airplane is, okay? And x number of seconds after it is thrown in the air, there's your x coordinate, okay? So any x coordinate you find is the amount of time since it left, in this case, Carter's hand, okay? The y coordinate is always the height that the airplane is at. All right, so first question here. At what height is the paper airplane thrown? What do you think?
5 feet.
It's 5. Why is it 5?
Because it's the speed.
Yep, it's your y-intercept. If it's when it's thrown, that's when x equals 0, okay? So I'm going to say this is when x equals 0, okay, which is at 0 seconds, where did it leave his hand? Well, it's the y-intercept, okay? So, therefore, y equals 5 feet. There's your answer right there. Okay. So 5 feet off the ground is where it left his hand. Now, if you take a look at B and C, kind of go together. When did the airplane reach the maximum height, and what was the maximum height? I say B and C go together because what am I really asking you to find in B and C? The vertex. The maximum height is the vertex, okay? So that's what this is saying. Find the vertex. Okay. Which, let's actually go ahead and do it. What form am I in? Standard. How do I find the vertex in standard form? Opposite of b over 2a. So x equals opposite of b over 2a. Opposite of b in this case is negative 4. If I double the a value, I get negative 2. And if I simplify that, we end up with a positive 2 to what? 2 seconds. That's your x coordinate. So 2 seconds after it leaves his hand, it is at the maximum height. Okay, 2 seconds. There's your first part right there. When did it reach its maximum height? 2 seconds. How do I find what the actual y coordinate, what the height is? What do? Plug it in. Yep. So, and again, remember parentheses. Y equals negative 2 squared plus 4 times 2 plus 5. Be careful about this part right here, by the way. That negative is before you're squaring, okay? So the only thing that's getting squared here is the 2. That's, again, part of the reason for the parentheses is saying, hey, that negative is outside of that. I'm only squaring the 2, and then it becomes negative. But again, you should at this point be able to plug this into your calculator, and you get 9, all right? Yeah, okay. So we end up with 9 what? 9 feet. Okay. There's your answer. The maximum height is 9 feet in the air. So it takes 2 seconds after it leaves his hand, and it ends up being a maximum height of 9 feet in the air. Okay, let's take a look at part D. After how many seconds does the airplane hit the ground? What am I asking you to find? The x-intercept. What I'm asking you, when it says when it hits the ground, that means y, our height, is 0. And if y is 0, that means I'm looking for the x-intercept. Negative x squared plus 4x plus 5 equal to 0. So, what are my methods to solve this? Factor or quadratic formula, either one, okay? Now, if you're going to try to factor this, you're going to want the x squared to at least be positive, okay? It's always much harder when the x squared is negative. So you could go through and either multiply or divide everything by a -1, and then factor. Do you want to factor or you want to do quadratic formula? I'll let you decide. Factor? Okay. So let's multiply everything here by a -1, or like I said, divide everything by a -1, either way. That way we get the x squared to be positive. So I'm really looking at x squared minus 4x minus 5 equal to 0. And now we factor. X times x, there's the first part. Now we go to the last, factors of the last term. There's only one set of factors. It's got to be 5 and 1. What do the signs have to be in order to get the middle term? We need a -5 and a +1, which if I put those again, -5x, +1x, it does give me that when I put those together. And when I multiply, I do get that. Okay? So now, finish the problem and solve. What does x equal? What's my first value? Yep, I get 5 and I get -1. What's my answer to the problem? Because the question says how many seconds does after how many seconds does the airplane hit the ground? Yeah, -1 doesn't make sense, right? You're going backwards in time. Okay, so 5 is your actual answer to the problem. 5 seconds is how long it takes. Now, quick question, only because I want to relate this back to some things that I saw on the test. We set up above that the vertex was at 2. And some people on the test said, well, if the vertex is at 2, all I have to do is double that, and therefore it should land at 4, right? Because of the symmetry. Why is my answer not 4? Why is it 5?
Because you didn't start at 0.
Exactly. Because you didn't start on the ground. Okay? It started 5 feet in the air. So there is still symmetry with that other -1 that was there. Okay? So if we take a look, that's the idea. I'm going to add one extra thing in here, just because I want to make sure that you understand domain and range as it relates to this. But ultimately, if I was going to go ahead and graph this, here's my, let's say here's 2, 9 right up here. There's my vertex. Just gonna label that. There's 2, 9. We just said what? -1 was where there was one x-intercept. 5 was where there was another one. We said the y-intercept was up here at 5. That's about right there, which we could then mirror over to the other side if we wanted to. But if you were going to actually draw in the path of this paper airplane, where does it start? It starts right here at 5. Yep. Remember, that's what we said, is where is it up in part A? Here's your starting point. It goes up to that maximum height, and then it comes down. There's your graph right there. Do I put arrows on there? Nope. We're not going to go through the ground. Okay? And anything to the left of this doesn't make sense because you're holding it, it's in your hand. Okay? So it doesn't matter. Anything, that point is irrelevant as it comes to the problem. Yeah, if we're taking a look at it in terms of the overall graph of a parabola, then yeah, then that would come into play. But it doesn't make sense according to this problem. Okay? So now if we put this together as domain and range, so that means my domain, I should have a maximum and a minimum value for x when we have an application problem. What's my minimum value? The minimum value of x. What is it? 0. Remember what x is. And if you need to, go back up to the top. Remember, x is the time. And if you just think about it, well, when does this whole thing start? When x equals 0. Okay? So that means I'm going to take this x and I'm going to sandwich it between my minimum value is 0. What's my maximum value of x? When does this problem end?
9.
Not 9. 5, right here. Remember x values.
Oh.
Starts at 0, ends at 5. Took 5 seconds to hit the ground. There's your domain right there. Notice it's not all real numbers because this is an application problem. It's not just some random parabola. It doesn't make any sense to go negative time, and after 5, it's already on the ground, so the problem is over at that point. Okay? Now if we do the same idea for the range, what's my minimum y value? Keeping in mind that y is your height. Nope. 0. It hits the ground. The lowest y value, it does hit the ground. So it's 0 again. What's my maximum y value? 9. That part is 9. There's your domain and your range. Anywhere between 0 and 5 seconds. Range, the height, is anywhere between 0 and 9 feet in the air. All right, what I would like to do, that was the main stuff that I wanted to talk about, okay? I wanted to make sure we went back over some of the just general equations and finding everything. I wanted to make sure we did at least one of these application problems so that you could see it put to use. If you look at the rest of this, now I did not have an answer key for the application problems. I didn't have a chance to go through and write one out. The next sheet that's in here was at the very end. Remember all the adding imaginary numbers, subtracting, multiplying, dividing. So I threw that sheet in there as well. Okay, we can come back and talk about this at another time, but this is something, again, some of the basics that you need to know. There is, again, examples on this one. So if you're taking a look and let's say you can't remember, again, here's just some examples as you work your way through these different types of problems. Okay, so you can use those to your advantage. And then for now, I would wait if I were you. Page. On the last part, come on. Come with me here. There we go. Oops. I would wait on this one because some of the stuff, especially in number 2, we haven't talked about yet. That's coming from section 5.2 that we'll talk about on Wednesday. Okay. But I did put the answer key to that as well. So with the rest of the time, I know there's only about 10 minutes left or so, but with the rest of the time, I want to get out of your way and give you an opportunity to just kind of work and practice on whatever you think you need. And I want to kind of quickly check in and just see where you're at. Okay? There's your review. Like I said, it's not an assignment. It's not anything you have to worry about, like I got to get this done and get it turned in. This is 100% for you to be able to practice and ask questions about. Okay? Yeah, that whole packet. Yep. What's that? Nope, neither one of them. It's all review. You don't have any specific homework for today. It's just my recommendation would be do some of the chapter 4 stuff. Work your way through whatever you need to work through.
5.1 is due today, right?
5.1 is due today, yeah. From 5.1 that we talked about before, so that is due today. Where you're talking about what are the different graphs, what are the names of them, and behavior and all that stuff. All right, while you're doing that, I am going to hand back your last set of tests and everything that I have to give you so that you have that back as well. So you can look back at your chapter 4 stuff. You can take a look at that. So let me give that back to you. 5.2 is not due until we haven't done it. When I copied it originally, I was going to put them together and then we changed it. So you have 5.2. You don't have to worry about it yet. Yeah, you can.
Well, we told my original test as well.
Yeah, please. If you can turn that in, yeah. Because I need to be able to see like what points you got there. There's a couple other way back, some other stuff you must have just on the other day. way old stuff as well. He must have been gone when I was,
Oh,
when I handed these back.
okay.
Yes, I think so. Be back, Lynn. And it's it, found one more. There's one more for you.
Dang, I'm really that bad.
There we go.
I hate math. I like math, but I'm never good at it.
There we go. All right. Let me check in with you and see how things are going and where you're at. The other option, by the way, just as a heads up, I didn't mention this, but as a heads up, if you think you're struggling at all, I would highly suggest you come in on Friday. That way we can go over some of the stuff. Because like I said, this is your last chance. There will not be any like retake, any corrections, any of that kind of stuff. So you want to make sure you do well.